The first law of thermodynamics is one of the most fundamental principles in nature. It states that energy cannot be created or destroyed during a process. It can only be changed from one form to another. In this series of presentations, we will develop a mathematical expression of the first law of thermodynamics, which can be used to analyze the energy interactions of a system. Let's start by taking a look at the different forms of energy that a system can have. First, we'll define our system as some fixed amount of an arbitrary substance. This system contains some amount of total energy, which is denoted by the letter E. The total energy contained in our system can be classified as one of two forms: microscopic energy and macroscopic energy. We will first look at the different forms of microscopic energy, which, as the name suggests, relates to the molecular structure of a system and to the degree of molecular activity. Each molecule within our system can have translational kinetic energy, rotational kinetic energy, and vibrational kinetic energy. In addition to the kinetic energy of the molecules, there is also energy in our system associated with the binding forces between the molecules, between the atoms within the molecules, and between the particles within an atom and its nucleus. The sum of all of the microscopic forms of energy within our system is referred to as the internal energy of the system, and is denoted by the letter U. Now we'll look at the various forms of macroscopic energy. Macroscopic forms of energy are those which a system possesses as a whole with respect to some outside reference frame. For example, the entire system may be moving at some velocity v, and will therefore have some kinetic energy associated with it. The system may also possess some energy as a result of its elevation in a gravitational field. This is called potential energy. Other forms of macroscopic energy, such as those related to magnetic, electric, and surface tension effects, are only significant in specialized cases and, therefore, will be neglected here. So for our mathematical model of energy, macroscopic energy consists of the sum of the kinetic and potential energies of the system as a whole. The total energy contained in our system, then, is the sum of all of the microscopic forms of energy, which is called the internal energy of the system, and the macroscopic forms of energy, which include the kinetic energy and the potential energy of the system. This is our definition of the total energy contained within a system that we will use to develop a mathematical expression of the first law of thermodynamics.